All right, today we're doing Unit 1, Section 4, Angle Measure and Bisectors. First thing we're going to talk about is what makes up an angle. When you have an angle, what you have is two rays, and the two rays come together at the vertex. And the rays have specific letter labels. Let's say this is R. This is S. This is T. So we could describe one ray as RS and the other ray as RT. Notice how the ray notation is directional and the arrowhead point goes over the pass point. Now, angles are made up of the rays, which are the boundaries, and then the internal part, which determines the measure, is the part inside. So if I were going to measure with a protractor, I would put the protractor down on the ray RT and measure here from 0 degrees up to whatever this measure might be. It kind of looks to me like it could be maybe 48 degrees. But that measurement comes from going from 0 degrees here on the right up to 48 degrees up here as measured by protractor. And I'm just guesstimating that because that's hard to show on the iPad. Now, this is an angle created from two rays. If I want to name the angle itself, I would do that by calling it angle S, RT. I could also call it angle T, RS. Just make sure that the vertex is the letter which appears in the center. Okay? Now, you can also refer to angles in different measures in different ways. For example, let's say this is X, Y, T. And from what we've talked about already, you might say this is line XT. You could say this is a combination of two rays, YX along with YT. You could refer to those as opposite rays. You could call this an angle also. This could be angle XYT, which would be equal in degree measure to 180 degrees as measured by the protractor. Or you could refer to this as a straight angle. Okay? Now, the inside of an angle, the interior is the yellow portion up here. The exterior is everything on the outside of the angle. And angles are classified. Different classifications, which I'm sure you remember from middle school. You can have a right angle, which is exactly 90. Let's call this angle MNO. Okay. You also could refer to other angles at different sizes. You can refer to this as an acute angle. We'll call this one LMN. Acute angles go from 0 degrees up to 90. And then, of course, the last classification, which I think most middle schools teach this, is obtuse. And I'm going to call this angle 4. That doesn't have anything to do with this measure. You can just use a single number if you want as label. This angle is from the degree bigger than 90, but it would have to be less than 180. Okay? Now, it's very common to see algebra values used in terms of angles. And angles also many times are related to something called bisectors. So I'm going to draw a larger angle here. I'll make this one BDE. And into this angle, I'm going to intentionally place a bisecting ray. So let's say the measure of the angle BDE is 110 degrees. Now, if I use this small m to describe the angle, that reads measure of the angle, and then I don't have to put the degree bubble behind the 110. Inside this, I'm going to put a ray that's called dx, and I'm going to make this a bisector. Now, when that occurs, this ray has to be in a specific place that's going to, in such a way, split this angle into two equal angles, kind of like slicing a piece of pizza. So B to D to E, the whole interior space, was 110 degrees. But now, because I have bisected this, I have created two smaller angles, which would be half of the 110. So I could say that the measure of angle BDX, trace it with your pencil tip from B to D to X, that upper interior, would be equal to the measure of angle XDE, and both of them are going to be equal to 110 divided by 2, which would be 50 degrees. Now remember, I used the little m, so I'm not using the bubble. Okay? Now, let me look quickly for an example using some algebra values, because those are fairly frequent in many problems. I'm going to draw this diagram. We'll put J here, K, L. Then I'm going to put one ray there with an N. Another ray here with an M. Now, many times these problems give additional instructions. KJ and KL, the ray KJ, the ray KL, are opposite rays. That would mean that every angle in this straight angle JKL has to add up to 180. That's just a reminder for me. In addition, KN, the ray, is going to bisect the angle LKM. Now, KN, the ray, that's the green one, is going to bisect the angle from L to K to M. That tells me that these two portions, even though I don't really have it drawn to scale, according to the directions, those two are equal. So that I must remember when I look at my problem. All right, the problem given to me is this. Measure of the angle LKM is equal to 7x minus 5. Measure of the angle LKM is equal to 7x minus 5. That would be this huge portion here. That's the 7x minus 5 section. The other instructions say that the measure of the angle NKM is equal to 3x plus 9. N to K to M. I'm going to change my color here. So the measure of NKM, N to K to M, that's only this portion. That is 3x plus 9. Now what I have to do is look to see what I've drawn here. The two light green arcs with the little slash through them, those pieces are equal. The large black angle, 7x minus 5, that's the total of the two equal pieces. And 3x plus 9, that is the same size as one of the light green angles with the little tick marks through it. So what is the relationship? It appears to me that two angles of the size of 3x plus 9 should be equal to the angle 7x minus 5. That's the relationship in the diagram. Now, relationships are many times very difficult to see unless we label. And I find it helpful to color code as you label so that you can see the differences. 2 times 3x is 6x. 2 times 9, 18, is equal to 7x minus 5. Subtract the 6x from both sides. And then add your 5. And that's going to be 23. X is 23. Now, suppose they wanted us to sub this back in. You could find the direct value of the degrees by subbing back in. So the portion that is 3x plus 9 we could find that direct degree measure by substituting the 23 for the x. So that's going to be 69 plus 9. And that's what, 78? So that leads you through today's lesson on 1.4, angle measure and bisectors. Bye.